everyone. Welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Yousef, who has completed the course ROS Basics in 5 days. And at the end of this online course, you can take a project and come present it. And this project is actually implemented on a real robot. So that's what we're going to be seeing here today. So hello, Yousef, how are you?
Hello.
Uh, I'm excited to see
Um,
your project. So please,
Thank you so
whenever
much.
you want, just start sharing your screen and show
Okay.
us what you've done with the project.
Okay. Is it good now?
Yeah, now it's good.
Okay. So this is my robot. I will start executing my launch file. No. I don't know why it's not working.
It's
Let me
Rust to
try.
launch.
Okay. Source install.
No, you were right. You just forgot the launch word. There you go. Now it will work.
Okay, so the robot starts moving. It's currently giving a feedback of the current total distance.
Uh-huh.
Once it gets back to the starting point, it will the odometry action is going to stop and send us a feedback, send us a result of this array of points. This is the odometry, the coordinates of x, y, z along the whole lab.
Okay.
Yeah, I made
Awesome.
this. I made the
And
presentation.
yeah,
Okay,
let me
sure.
just ask you a couple questions
Yeah,
real
sure.
quick. Uh, Can we stop it? Oh, it did stop. Oh, no, it's not. Yeah, can we stop it, please?
Yeah.
Perfect. Just so we don't have it running in the background. Great.
Yeah.
Okay, and I didn't see the first section of the project, which was finding the wall. Do you
Yeah,
mind
sure.
stopping that, like beginning, redoing that part? Because I couldn't see it.
Let's say that we are here. Okay.
Uh-huh.
And then I'm gonna execute the code one more time. It will start looking for the wall.
Oh, it's spinning right now. Oh, it's a little laggy. Okay,
Yes.
okay, okay, okay. I got it, got it. All right. Okay, please now continue with your presentation.
Yeah, so I made this little presentation. Um, the whole point of the project is to make the ROS, the Turtlebot, follow the wall while maintaining this specific distance to the wall, 30 centimeter. But we have three main nodes: the find the wall, follow the wall, and record odometry. This is the behavior that the robot is going to do. Uh, First, wall finding, using the LiDAR, we are going to calculate all of the 360-degree laser, okay? And then we will take the minimum value that the LiDAR has calculated, and then we will have three main conditions. Uh, Here I discussed these two. If the closest wall isn't facing the robot, then it will rotate until the robot is facing the closest wall, meaning like I'll keep rotating until the front laser is is actually calculating the minimum value. Okay, and if the closest wall already facing the robot, then we will skip the rotation part because we don't actually need that. And then after the robot is facing the wall, we are going to move forward or backward until the wall distance equals to 30 centimeters. Okay. And eventually we'll rotate until the right laser equals to 30 centimeter. Then we will know that we are in the proper position and the service will be over. Okay, we will skip all that only if the right position or the right laser is already equals to 30 centimeter. You get me? Like we won't need to do all the service process because we are already there. Okay. Then the wall following. The wall following is pretty simple. Like we move the robot forward after like the wall finder service is done. We're gonna know that we are in the right position. So the start wall following behavior is gonna start executing, and basically we'll keep moving forward as long as the distance to the right is equals to 30 centimeters approximately. Like it'll get less or more than that, and the distance to the front got to be more than 50 centimeter. All right, and while the robot is moving, we're gonna have a little of deviation, so we'll move slightly to the right or to the left to stay on a straight line. Okay, so in the end, when we have like the front laser calculates less than 50 centimeter, we're gonna rotate counterclockwise until the facing of the robot is completely clear. And this algorithm is going to keep iterating. And as mentioned here, the wall following node presents the core of the project because it makes the other nodes have a real purpose. You get me? It connects everything together. Eventually, the recording odometry, we're going to send the recording odometry request once we are in the right position also.
I'm sorry, Yousef, can I interrupt you for a second? There seems to be
Yeah.
something strange with your microphone, and it's hard to understand. Maybe
Okay.
unplug it and plug it back in or something?
Okay, that's right.
Can you hear me?
Hello.
Now I can hear you.
You can hear me?
Yes.
Okay,
You
good.
just sounded very raspy.
Um,
But let's see. Please continue. Please continue.
okay. So the recording odometry, as soon as the robot is in the proper position, we are gonna start. We're gonna send a goal to the odometry node. It's gonna start taking action. First, we will save the initial coordinates of the robot in independent variables. Okay, and then we are going to store new coordinates in the list of odom array. Okay, and then every second we're going to calculate the current distance. We're going to keep calculating the current distance until we finish one lap. The odometry action will stop, and at the same time, we'll be sending the current distance as a feedback. So that's all about that. This is the whole presentation that I made. Should we like move to the code part?
That's it? No. I mean, it's up to you to present what you want to present.
Yeah, like I finished that. If you want to see my code.
That's all right. I don't need to.
Okay. Okay. That's everything.
I'm sorry. Repeat that.
I said that is everything.
Oh, okay. All right. Great. Well,
Okay.
thank you, Yousef, for
Okay.
your presentation. Let me go back here too. Do you mind stopping sharing your screen so we can take a look at your
Yeah.
face while I ask you some questions?
Sure. Sure.
Awesome. So, all right, great. Very clear and straightforward. So, congratulations on your presentation. I wanted to ask you
Thank
two
you so much.
questions besides the ones I already asked you. And
Yeah,
the
sure.
first one is in your feedback messages on the output of your terminal, I saw a
Yeah.
lot of UID output. What is that?
UID here.
Yes. So in the
Um,
output for your feedback, there was like a big
yeah,
string, and it said UUID. Uh,
this is the address, or maybe the address for the node that is sending the message or the feedback, maybe.
what I think is it's a problem how you're printing out just a
Oh,
thing, how you're printing
okay.
out the feedback. I think you're printing one level up or something. So it's printing out like when you print out an array or something that's telling you the type and everything beforehand. I think.
Okay.
Um,
Okay. Yeah.
just
Yeah. Makes sense.
doesn't mean that anything's wrong, but just for
Yeah. Yeah. Makes
understanding.
sense.
All right. And then the other question I had was I noticed the robot was really fast while doing the lab. How did you do it so fast while at the same time avoiding missing sensor data or your control loop not getting there at the time it needed to for the speed of the robot?
Well, I actually built my robot, built my code step by step. Like I tested every step until I got to the desired result. You get me?
Yeah, yeah. But my
Yeah.
question is more on the lines than on the rate at which you're running your node. How are you running the rate at which your
Oh,
node is
okay.
spinning?
I see. Yeah, I created like a multi-threading callbacks. You get me? Maybe that's why it's so fast.
No, no,
Like every
that would
callback.
be so your node
Oh,
is
okay.
actually
I get you.
spinning. So that way
I get you.
it keeps going.
Yeah.
It wouldn't
The,
get
the
stuck.
I'm publishing in my code. I'm publishing the twist commands from the same laser callback. Uh,
Oh,
you
okay.
get me? Like as soon
Yes.
as I get the results from the scan topic, I will execute the command publishing.
Oh, I see. I
Yeah,
actually
I'm
don't recommend that to
I
keep doing it that way because if you for some reason do some operation in your sensor callback, any sensor callback, that
yeah.
takes longer than the time for a new message to arrive, then you lose that new
Okay.
message. So just as a suggestion. But all
Okay.
right, my point was that you're spinning your node fast enough to be able to handle this high speed. I mentioned this because a lot of students say, I have to go really slow, otherwise it'll run into the wall, and they think this is something intrinsic of like the hardware. It's like no, you make this behavior in the node that you write. So
Yeah,
I like
I
that
get you.
that it didn't miss a beat. So nice on that. And other than that, Yousef, that's all the questions I have. So I just want to congratulate you again, and yeah,
Thank
good
you so
job.
much.
All
Thank you.
right, let me switch back here to my screen, and yes, this is what you can do, guys, when you take our online courses that offer an online certificate. The way you can obtain this certificate is by presenting the project that we offer in that course. So I invite everyone that is taking our online courses to do what Yousef did here and go ahead and present with us to showcase what you've learned and taken out of our online courses. So thank you guys for watching, and we'll see you guys next time for the next presentation. Bye-bye. Okay, cool.